know you're all getting super excited, just waiting for that day that we're going to start proofs. Well, we're one day away. We got one section left, and then we'll start getting into proofs. But first, we got to talk a little more reasoning before we can get there. So we've done inductive reasoning, and I'm going to write that up there because we got to talk about inductive reasoning again. And now we're going to talk about deductive reasoning. Well, before we get into deductive reasoning, let's talk about inductive again. Remember, inductive reasoning, you look at examples of what has happened before, or possibly look for a pattern. You basically look at the past and look at your occurrences and use examples or patterns to make conclusions. Where deductive, we're going to use facts, rules, definitions, or properties to reach logical conclusions. So we actually want to use factual information, not looking at patterns or examples of what's happened, but things that we know for sure. So it's different between the two here. So determine whether each conclusion is based on inductive or deductive. So in Miguel's town, the month of April has had the most rain for the past 5 years. He thinks that April will have the most rain this year. So did he conclude that because of deductive reasoning or inductive reasoning? Well, if you look, he's looking at past examples or a pattern, isn't he? The month of April has had the most rain for the past 5 years. Those are examples. It's a pattern of what has happened in the past. And so that would be inductive reasoning. Inductive reasoning. Okay, because he's using patterns or examples of what's happened before, not facts or anything like that. Whereas the next one, Sandra learned that if it is cloudy at night, it will not be as cold in the morning than if there are no clouds. Sandra knows that it will be cloudy tonight, so she believes it will not be cold in the morning. So she knows this fact, this scientific fact, that if it's cloudy at night, it will not be as cold in the morning. So she believes, since it's cloudy tonight, it won't be cold in the morning, so she's using a fact or a definition, so we would say that is deductive reasoning. So there's the difference between the two. And some of our reasoning leads into some of our laws that we have. We have two different laws we're going to talk about today. The first one is law of detachment. This goes back to our statements implying each other. So if P implies Q, so I have two statements and one implies the other. If that's a true statement and P happens or P is true, then Q has to be true according to the law of detachment. So if P implies Q is true and P happens, then Q has to happen. So let's take a look at an example. If a car is out of gas, then it will not start. So this condition is true, right? P implies Q is true here. Well, if that's the case, and we say that Sarah's car is out of gas, so now we're saying that P is true, right? P just happened. I can conclude that Sarah's car will not start. Right? So Q has to be true. So if the condition is true, if P implies Q is true, and we say that P happens, Sarah's car is out of gas, well then we know that Q has to happen, so Sarah's car will not start. So that's the law of detachment. Let's see if we can come up with that looking at an example here. So this says determine whether the conclusion is valid based on the given information. If not, write invalid and explain your reasoning. So given, if a figure is a square, then it is a parallelogram. Well, if a figure is a square, let me think about that. So I got a square, that could happen, that's true. Then it is a parallelogram. Well, a parallelogram just has two sides that are opposite that are parallels. Two pairs of opposite parallel sides. Well, the top and bottom are parallel and the sides are parallel, so it's a parallelogram. So this conditional is true. All squares are parallelograms. So now it's saying the figure is a parallelogram. So basically it's saying that Q is true here. Well, if Q is true, does that necessarily mean P is true? If a figure is a parallelogram, then would the figure be a square? Well, this is also a parallelogram, isn't it? I got a pair of sides that are parallel, opposite sides that are parallel. And that's not a square, so this is invalid. This is invalid. The law of detachment does not work here because we said that Q was true and not P there. And explaining my reasoning is right there. I drew myself a picture. I showed that that parallelogram is not a square. Okay, so if the condition is true, like it was here, P has to be true. The first statement, the hypothesis has to be true in order for us to conclude that the Q is true. So like here we're going to use the law of detachment correctly, but we're going to explain our reasoning using a Venn diagram this time. So if a triangle is equilateral, then it is an acute triangle. So if I have an equilateral triangle, let me draw one as close as I can. Pretty close. A little off, but not too bad. If it's equilateral, that means it's equiangular. So all angles would be 60 degrees because they have to add up to 180. 180 divided by 3. Well, that's an acute triangle, isn't it? So I'm saying that the triangle is an equilateral. So I'm saying up here I said P implies Q. That's true. And now I'm saying the triangle is an equilateral. So I'm saying P is true. So I can conclude that Q is true, but I'm going to use a Venn diagram. Well, if it's an equilateral, then it's acute. So all equilateral triangles are acute, aren't they? So let me start with my circle here. So these are equilateral. I'll just put equa triangle, something to know. I know it's an equilateral triangle. All those are acute, right? But not all acute triangles are equilaterals, are they? I can have an acute triangle that's not equilateral. So that means my acutes have to be the bigger one. Because all equilaterals are acute, right? But not all acutes are equilaterals, right? I could have something that's like, 40, 70, and 70 for an acute. That's not equilateral. Okay? So that would be an example of a Venn diagram to explain that there. We also have the law of syllogism. The law of syllogism, I like to think of the transitive property. Because if P implies Q, and then Q implies R, we know that P implies R. Okay, so if those are true statements, then we know that P implies R is also true. So it's kind of like the transitive property, like if A equals B and B equals C, then A has to equal C. It's kind of like that, except we're using our if-thens and we're implying. So for example, if you get a job, then you will earn money. Well, if you earn money, then you will buy a car. So basically I can state that if you get a job, you will buy a car, right? So if I say P implies Q is true, and then Q implies R is true, P would also imply R. So if you get a job, then you will buy a car. So it's kind of like that transitive property. Let's take a look at an example and decide if this is possible. And if it is, then say if it's the law of detachment or the law of syllogism. And then if there's no conclusion, we'll say no valid conclusion and we'll explain why. So given, if it snows more than 5 inches, school will be closed. So here's my P implies Q. And that's true, okay? And now I just said it snows 7 inches. It snows 7 inches. Well, the snow more than 5 was P. School will be closed is Q. And it snows 7 inches. So I'm saying that P happened, right? P is true, isn't it? It snowed more than 5 inches. Well, if P implies Q is true and P happens, I can conclude that Q happens, right? I can say that school will be closed. And that is what law? That would be our law of detachment. So if you can draw a conclusion, tell me what you conclude. Tell me what law it is. If you can't, then say no valid conclusion and tell me why. So just a few things about deductive and inductive reasoning and our 2 new laws, law of detachment and law of syllogism. Proofs next time.